Okay, so here's the last example from the notes yesterday. This one has two ships leaving a port at the same time. One ship is sailing in the direction north, 23 degrees east, at a speed of 11 miles per hour. The second ship is sailing in the direction south, 67 degrees east, at 15 miles per hour. It wants us to approximate the bearing from the second ship to the first 1 hour later. So what I've gone ahead and done already is I've drawn a picture. So on this picture, I have their starting point. Since the first one went north 23 degrees east, I know I went up, and then 23 degrees to the right was their general bearing. So the angle between our vertical axis and where my ship went was 23 degrees. The second ship went south, 67 degrees east. So again, I went south or down, and then to the right, and it was an angle of 67 degrees with the y-axis. So what it wants to know now is after an hour, what is the angle difference between ship B and ship A? So the first thing we need to do is figure out how far they went in that hour, which is really easy because I was given their miles per hour here. So then what I need to do is I need to kind of see what this is taking on or what shape this is taking on. The first thing I notice is that I know a straight line is 180 degrees. So when I subtract 23 and 67 from 180, I get that the ships formed a 90-degree angle when they took off. And then if I connect where ship A is and ship B is, I see that this has formed a right triangle, which means I can use my trig functions. So what I want to do right now is I want to solve for the angle right here. In the end, I need to see the angle difference between ship B and ship A, which is going to be this little blue angle right here. So I need to fill in all the angles between the 67, the inside of the triangle, and that one to figure out the angle difference here. So I'm going to go ahead and use tangent because I have the opposite side and I have the adjacent side. So we're going to have tangent of angle B is equal to my opposite 11 over my adjacent 15. Obviously, I'm solving for an angle here, so I'm going to have to use my inverse function. So I'm going to use tangent inverse in degree mode, of course, of 11 over 15. And that's going to give me my angle B. We can go ahead and round it to the nearest whole number. I think it might be easier here. So when I do this, I get 36.3, which we can approximate to 36 degrees. So that means that this little portion inside of my triangle at angle B is 36 degrees. What I want to know is what this portion is right here, because that's going to be the angle difference between ship B and ship A. So I know that this whole thing right here is 90 degrees because it's a right angle. So I can do I'm going to do 90 minus 23 degrees. And then minus 31 degrees. And that's going to give me, minus 36 degrees. And that's going to give me 31 degrees, which is going to be this difference right here. I went ahead and used 23 here because I know from geometry that this angle has to be equivalent to this angle. That's just an alternating interior angles property. So I went ahead and filled that part in. When I filled that part in, I got this angle, which is going to be my bearing here. Another way you could have found what this angle was is we could have done 67 and 90 and then subtracted from there and you still would have gotten 23. Okay, so we needed to find this angle to add this angle to it to solve for that angle. So once we have this one, I just need to figure out the direction of that angle. So from point B to get to point A, I would have to go north and then I would have to go west. So the bearing from ship B to ship A would be north, 31 degrees west. And then that would be my bearing. I'm not going to put one like this on the test, but it's still not a bad idea to know how to do it. Okay.